Hello class, George here, and we're in the final video for the memory application that we've been making, and this is going to be sort of the brunt of the game mechanics and rules. We're creating our game activity now. Now this is going to need to do several different things to set the game up. The first is it's actually going to need to create our memory buttons for us. It needs to attach them to the grid that we have. For us, the grid view has a ID that we had put on. It's also going to have to handle the on clicks of the buttons. And this is a case where I found the activity implementing on click was just as easy, if not easier, than having the an anonymous class do it. We're also going to have to handle all the different resource files, or the drawables really, the resource drawables. And when we create those instances, we need to make sure that we give each one the right instance. We basically have a grid of 4x4, so that's 16 total options. And because it's a matching game, we have to have an even number because there's going to be 2 that match in our case, so 1 and 1. Therefore, we're actually going to have 8 unique different graphics we need on the screen, and we're going to want to lay them out 2, 3, 4, 5, 6, 7, 8, like this. This is actually how we're going to do it. We're going to iterate through it and just place our numbers, and then we're going to do a randomization function that's just going to iterate through each of these and then randomly see whether or not it should swap with something else. And it will. So we'll go through for this element, it'll try to swap with something random around here. We'll go to the next element, find a random value to swap with through all of them. And hopefully that'll give us enough disorder to where it's a fun game. And of course, this is a very simple algorithm. You can make it far more complicated and far more interesting. Make multiple checks where you make sure that no number is next to itself, that kind of thing. We're also going to implement something called a handler. And this is kind of interesting, and it's a little early to really get into this, but I wanted us to be able to delay execution. And that's because if you try playing this game and you were to click on a value and then click on another one and it wasn't correct, instantly they would turn off. And you wouldn't even be able to see what the value was originally. So we're going to use a handler to delay the flipping of these objects. But because we're delaying things, and it's possible for the user to multiply just button mash things, it's possible to actually crash our game in the state that we're going to make it. So we're going to add to it a bool value that is going to basically say, are we busy? Meaning, has the user chosen 2 wrong options, and are we in the process now of giving them some time to see that they've made a mistake before they're allowed to make a new entry? All right, so with that, let's just go ahead and dive in code and explain this a little bit further. All right, so here we are. So let's add some of those things that I was talking about. Let's do private int number of elements. That's going to be how many elements we actually have in our 4x4, which will be 16 in this case. Private memory buttons. So it looks like I made a bit of a mistake. I had created the memory button class under a completely different directory structure over here. So I'm just going to grab this and actually move it to where it should be. Let's go ahead and refactor that so it fits in properly. That's probably why I couldn't find my R file from before. Come back in over here, and now we can find our memory button class. So we're going to create a private field of memory buttons. It's going to be an array of them. It's going to hold all of our buttons for us. Now I'm going to create 2 additional arrays, and it might not become immediately understood why I'm doing this, but it has to do with how I want to hold information. And I like arrays because they're easy to iterate through. And in my case, I'm going to store an array of what each button's resource should be. That is, this array here is going to hold a list of all the different combinations that we have. So it's going to have 2 1s, 2 2s, 2 3s, 2 4s, etc. And then we're going to randomize this list. And that random locations of each of those objects is then going to be used to determine which graphic each button has. It will make more sense in a minute. I'm also going to create an integer array of button graphics. And these are going to be the actual IDs we're storing. All of the different values we have to use, the r.drawable.button123 files, but just stored in an array because everything else is in an array. And when I do iterations over things, it just makes stuff easier. We're going to create 2 different fields here, and it's going to be a memory button, and it's going to store a reference to the selected button 1, which is the first one you selected, and then another memory button. Now, the reason I have 2 memory buttons, not just 1, is because during that time interval where I want not an animation to have, but a hold to happen on the system so the user can see when they made a wrong answer, I need to store a reference to both of those values because the system is going to, well, you'll see, but the idea is I need a reference to them so that our function, which gets executed later on, can still hold those values. And now we're going to do a private boolean is busy. And this is busy is what's going to keep things from crashing when we're deferring a task from making sure the buttons flip back over after you've made a wrong choice. So now we're in OnCreate. Here we are with the OnCreate.super. Here we are. We're creating our activity. We're inflating our layout right here. And now that the layout's inflated, all we have is that grid view. But now we can do a grid layout, and we need to Alt-Enter to include that, is going to be equal to, typecat this over to a grid layout. Let's do a find view by ID, r.id dot grid dot. It looks like we didn't give that grid a name, so let's go over there and do that really quick. So here we are, text, yes, no ID for this grid layout, so let's do that. Android, ID is equal to, @ ID / and we'll call this, let's call it grid layout 4x4. Not that it really matters too much, but we are actually going to use the fact that we have a column count and a row count to determine how many values we can store, just so I can show you that you can't access that information in code. Okay, so back over here, now we can grab that. So let's do find view by ID. It's going to be r.id. And there's our grid layout 4x4. Once again, that's going to be type, the standard view type, so we need to typecast that over. And then let's do grid layout. Grid layout is equal to this. All right, so now let's determine how many columns and rows we have. Now, we know we have 16. We've made a 4x4 layout, but if for some reason you did want to determine from the layout itself, maybe, for instance, an artist has made several different layouts, and based upon the button the user presses, different layouts actually happen. So let's move logcat down. There we go. Let's do int num columns is going to be equal to the grid layout dot get column count. We can do int num rows is going to be equal to also the grid layout dot get row count. And now we can populate that field we had up here. Do we not make this field? Apparently I've been coding in the wrong view, everyone. Let's move this over into the game view over here. So we want to take the grid layout portion right here and bring it over into the other one. So let's do that. Control X. Nothing big, just a little bit of mess up here. Put this here, and we're back to where we should be. All right, so now number of elements can equal the number of columns times the number of rows. Simple math. Let's start instantiating some of those arrays, right? So let's do buttons is going to be equal to a new array of memory button, and it's going to have the number of elements equal to that, equal to number of elements. Yeah, there we go. That's why we calculated it, so we can use it there. Let's also create button graphics is going to be equal to integers, an int array, a new int of size. Now this is going to be equal to half the number of elements because it's a memory game, 2 sets, 2 of each. We have 16 in this case, divided by 2, that's 8 total. And that's all I ended up making. I have buttons 1 through 8 over here. So let's do button. And now we're going to actually grab each of those buttons here and place them manually. So we're going to grab drawable.button1. I'm just storing these off into a list to make my life a little bit easier. 2, 3, 4, 5. All right, so we have those all stored away now. Now let's do button graphics locations, which is going to be that array that is going to be all mixed up, and it's going to let us know which one of those different button types each of the buttons should have. Which each of the drawable graphics each button should have. Now what I want to do after this is actually go ahead and shuffle things up, but we need to write that function. So let's go ahead and jump down and do that. This function is going to be called shuffle button graphics. So let's create that here. Protected void shuffle button graphics. We're going to first need to be able to randomly place things. So let's do a random. Rand is going to be equal to a new random. There we are. Include that if it hasn't already been. Now I need to fill in the default values for button graphic location. So let's create a loop here and fill in default value. That is, I want to fill in 2 of each number. That is 2 1s, 2 2s, 2 3s, 2 4s to relate to this array we have here. And then we're going to mix them up after we've stuck them all in there. So first they're all nice and ordered, then they're all going to get mixed up. That's the order I'm doing this in. Int I is equal to 0, I is less than number of elements, I++. You could do this other ways. You could create a list of all of them and then pop them off and then put them in wherever you want to. I just like doing it this way because it's really easy. So we're going to do I modulus 8. What this is going to do is this is going to iterate over all the elements. And since I know actually, if we want to be really good people here, it should be number of elements divided by 2, actually, because we don't know what the number of elements actually is, even though we're kind of hard coding it, so this is a little bit better. What we're going to want to do here is we're going to take all of our even number, and then this is going to go from 0 up to that number, and then we're going to modulus it by half that value. So we're going to get a value of 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7. And that'll fill up this entire set in a consistent pattern. Then after this, we're going to do another loop now. So let's do that other loop. So 4, let's just do another int I is equal to 0. I is less than number of elements. And you can change this. You can make it loop over it more to make it more random. I'm just going to do one pass. And what I'm going to do now is swap things around. So I need to do int. Whenever you're swapping stuff, you always need to have a placeholder. So we're going to do a temp is equal to button graphics location I. We start at 0, then 1, then 2, then 3, then 4. I know I'm going to do a swap, so I'm going to store whatever one I'm currently on, so I know I don't lose that value, that index that we want to work with. That's the index we're going to use to access the graphics over here that are going to be sent along to our memory buttons. So now we're going to do int swap location is going to be equal to rand.nextInt. So this is the index that we're going to want to swap it with. We have a chance of this particular value here getting swapped with anything from 0 to 15 in this index. I could call it swap location or swap index. Index might make more sense actually. So let's call it swap and index. Let's do button graphic locations. Whatever one we're currently on is now going to be equal to the button graphic locations swap index. So that's going to swap those two. And now all we need to do is make sure that at button graphic locations, wherever we had done the swap, we place that original value back in there. And that's our swapping procedure. So now that we've shuffled things up and we've got a list of randomized different integer values and where they should go, we need to create those memory buttons and then attach them to our grid. This is going to require a double for loop just because it's easy to do that way, because we're going to iterate over every row and every column, create a memory button, set an ID for it, or create in the program an ID instead of doing an XML. And then we're going to give each one of them a listener. Actually, we can't quite do that yet. We actually need to implement that here. So let's do implements OnClickListener. Click over here, make sure we implement those missing methods. There we are. So there we are. We'll leave that blank at the moment. So let's go ahead and start for, and int r is equal to 0 for the row. R is less than the number of rows. R++, and this is where I get a big kick out of this next one. So int C is, I shouldn't get a kick out of it because I'm in Java world right now, but I do program in C++ a lot, and getting the chance to write C++ is just, it's stupid, but I enjoy doing it. Okay, so let's create a memory button now. So memory button temp button is going to be equal to a new memory button. The memory button requires us to fill in all this information. First is this, which is the context, which is this activity. Next up is our row, which is going to be the R value, and then the C value, and then finally the front image drawable ID that we want to use for this thing. We're going to get that, and this is a little complicated, but bear with me here. It's going to be button graphics, right? Because the button graphics hold the actual resource values, the integer values, right? But we need to know which one we need to pull in. And we've already created a list of randomized ones, right? And those are held inside of the button graphic locations, or indices. Probably indices would have been a better name. So we're going to use inside of that, and then what we want to do is grab the current element we're on in that. We want to take the row and column value and convert that over into an index value. So instead of being the row and the column, I want to know the absolute one that I'm at. And that requires a little bit of math. So we're going to do R, which is the current row we're on, times the number of columns, and then we're going to add to that our current C value. Hopefully that makes sense to you. The idea is that we're this many elements in, so if we're on row 0, this goes to 0. If we're on row 1, it skips us ahead 4 units, so forth and so on as we go along, and we add to that the current column we're on, and that's how deep we are in that. This is how we convert from a 2-dimensional list notation to a 1-dimensional list notation. Okay, now let's put a semicolon on the end. New memory button. Pass it the context, pass it the R, pass it the C value, and then pass it the particular R.drawable thing that it should be referencing, the ID of the drawable it's going to access, the image it's going to be using for its front value, and that is done through this double array right here, where these ones store all of them in a nice order, and these ones are randomized values that are between 0 and 7. And with that, we just do a grid layout, which we still have, luckily, dot add view, and we pass it our child, our temp button. no, if I spell it right, there we are. When we create our views this way, we're not going to have an ID. That is, remember the IDs in XML that we're using to reference things in our activity menu? Down here, we've got a button and we have that ID, and then we have that @ to force an ID to be created. Well, where the hell do we do that? Really easy. We can do that in code. Android, since I believe API 17 has made it very easy for us to grab new IDs. Now, IDs don't have to be unique. But if you want to stick with the uniqueness that Android provides you when you look at your R file, we can use it to help us out here. So let's do temp, oh, I spelled it wrong here, button, there we are. So temp button.set ID, and we just pass an integer. You could do whatever you wanted to, but you always have the chance of your integer value clashing with other IDs that Android might set up inside of here. And that's the last thing you want to try to debug later on. So it's better to let Android come up with the ID for you. So let's do view.generate view ID. It's as simple as that. Now we need to set this button's OnClickListener, and that's going to be this, because this activity has implemented this interface up here, view OnClickListener, and it will be calling this function right here, method, whenever it happens. One other thing I like to do is just store these buttons away for future use in case I need them. So in our buttons array, we're going to do buttons r times num columns plus c is going to be equal to temp button. Just storing it away. Don't really have any use for it right now, but you don't want to lose those references. You'll probably need it at some point. So the last thing for us to handle is that OnClickListener right down here, the OnClick method. This is not going to be difficult at all. We're just going to have to check a couple different states to make sure that everything's set. First thing we're going to do is we're going to see if we're busy. This might not make sense yet, but I don't want to process user commands if we're busy. This is because we could potentially crash the application if the user starts button mashing things while I'm still waiting for my handler to flip over the tiles or the buttons. So first thing we need to do is memory button is going to be equal to, typecast this thing on over to a memory button. Now we have access to all that wonderful functionality like flip and so forth by typecasting it to a subclass. And since these are the only views we have on this screen, I don't need to really worry about that not being the right thing. So the next thing I want to check is to see whether or not if button dot is matched. That is, if this button has a match, return. So if it already has a match, you know, why did you press it? Nothing should happen in this case, so ignore it. Next up, we're going to handle the case if selected button 1 is equal to null. Why am I doing this? If selected button is null at this point, it means that you have clicked a valid button and we've never clicked another one before, or we've reset things. Therefore, I need to store your selection away because I need to wait for your next one to see whether or not a match has been made. So we're going to set it equal to button, and then we're going to do selected button 1.flip, and we're going to return after that. If you want to, you can do if else stuff. This is just how I ended up programming this one out. Next thing I'm going to check for is if selected button 1.getID. So this is important. This is why I created IDs for these views. I wanted to see whether or not the user pressed the same darn thing twice. If you press the same damn thing twice, I'm not going to do anything. I ignore it. All right, so next up is if. So we've gotten to this point, it's not a matched value already. This is no longer null. We didn't press the same thing. So if selected button 1.getFrontDrawableID is equal to button.getFrontAndDrawableID. That is, remember, the drawable ID is the image. It is the integer value that defines which resource we've bound that object to show on it. And we can use them to differentiate one button from the other. If they match, that means you win. You did a great job. So what we're going to do is we're going to do a button.flip. We're going to flip the button you just pressed. Remember, the other one, the selected button 1, is already flipped, so we don't need to do anything. We're going to do button.setMatched to true, so that, yes, we can tell you that that particular one is true. We're going to do selected button 1.setMatched is also going to be true. Let's do selected button 1.setEnabled. And what this allows us to do is enable or disable a button. And I don't want to let the user be able to press these buttons again, so we're just going to disable them. Normally this would turn the button grayed out, but because we're putting a background image on it and everything, you really don't notice too much of a graphical difference. It just looks like it's continually depressed forever. And the last thing we're going to do is we're going to set selected button 1 back to null. And we're going to return. Else, return's really superfluous at this point because I have an else clause here, but I'll leave it. Doesn't matter. Selected button 2. So what we're down to here is this is not a match anymore. This was a match. We've handled every single case except for if the user chose two ones that are not the same. So let's do selected button 2 is going to equal to that button you selected, and selected button 2 is going to be flipped. Now this is the part where we're going to deal with something a little strange, something we're not going to get deep into until later on, but we have the ability to basically delay execution of a method. And that method will happen later on in the main UI thread. And once again, these things might sound confusing, but all you need to know is that when you're dealing with the main user interface part of your application, which is what we're doing now because we're not dealing with games yet, and we're not dealing with our own threads, handling the graphics and so forth, in here, we can create something called a handler. And that handler can take in a value, an anonymous class, or an instance of what's called runnable. And in runnable, you have a function called run, and inside of run, you can do whatever the hell you want. You can break things, obviously, but the idea is you can write any code you want to, and that will be executed at some point in the future after a delay that you get to specify in milliseconds. Let's see what that actually looks like. We're going to do a final handler is equal to a new handler. So that's declaring the handler right there. Make sure we include that in here. Make sure we use the Android OS version. And now let's do handler dot post delayed. We want to delay posting or calling a particular method. We need to create a new instance of runnable. And it's an anonymous class, just like before, inside of here. And we get to fill in this portion right here. Now there's one piece we're missing, and that piece is how long we want to delay things. I'm going to delay things by 500 milliseconds, which is a good amount of time. Semicolon on the end of that. That's in the wrong place. Let's do that. And a comma there. That should be better, right? No, you need to close that off, don't you? Is that better for you? Does that work? There we go. Got to make sure all those parentheses match on up. Okay, so inside of run, what we're going to do is we're going to do select the button 2 dot flip. We're going to flip it back to wherever it was, which will be on the back side, and we'll do selected button 1 dot flip as well. And we're going to do selected button 1 is equal to null, and selected button 2 is equal to null. And the last thing we're going to do is once we've finished up all that stuff, we're going to set busy equal to false, which means the user can now make new presses. And with that, fingers crossed here that I didn't screw something up, that's the entire project. So let's go ahead and run it. So I have my phone hooked up right now. So let's go ahead and bring that over here. And that's the old memory one. All right, so here's our game, memory game, 4x4 game. Click that. Oh, okay. So we're going to have to adjust the gravity inside of our grid view to make sure that these things are centered, but this is fine for the moment. So let's go ahead and click an object. It swaps over to the other graphic. Click another one. Those are different. Perfect. It waited, stalled for 500 milliseconds, and then, it didn't stall. I'm sorry, that's the wrong thing. It delayed flipping those for 500 milliseconds. Click two more. 8, 1, 2, 4, 6, 4, 6. So this is interesting. We got a null pointer exception here. I haven't seen this yet, so let's take a look at it. Let's go to this line right here, and it's saying selected button 2 dot set enabled. Ah, so it's saying that there is no selected button 2 in this case. And that actually makes perfect sense. There is not one right here. Let's do button dot set enabled. There we go. That's the problem. We're not dealing with button 2 yet. We're only dealing with button 1. Button 2 is only there when we have to hold on to a reference past this function in the future, or this method in the future. Let's go ahead and stop this. Start it up again. All right, so we're back again. Let's hit 4x4 game, and let's start playing around. So there's an 8, there's a 3, there's a 7, there's a 6, there's a 2, there's a 2. So they matched up perfect. Let's select two different ones. They all worked fine. There's a 3 and a 3. That works as well. 4 and a 7. Let's start button mashing and see if we can crash things. Clicking on the same ones with no problem. It's not causing any issues, and I'm going pretty crazy here. And it doesn't matter because we put that is busy loop in there. No problems now. We're not getting a null reference issue. Now it's up to you. Go ahead and take this and make it more than it is. Spend some time, record whenever you actually do make a match, and see if you get a total of 8 matches. And if you do, put something down here that says, hey, you won, good job. Or you know what? Extend this. Make multiple different activities that handle different layouts and different sizes and see how it works for you. So that's it for this particular portion of the lesson. Hopefully you saw this as a fun little exercise using some of the basic knowledge you have right now of Android to do something interesting. All right, thanks everyone. See you next time. Bye.